Weathering. Pebbles and sand are pieces of rock. Pebbles are pretty big. You can count a handful of pebbles. Pieces of sand are tiny. You can't count the particles in a handful of sand. All pebbles and sand particles start out as huge masses of rock the size of mountains. How do mountains break down into pebbles and sand? The answer is weathering. Weathering is the breaking apart of rocks into smaller pieces. Weathering happens to all rocks when they are exposed to water and air. Physical weathering. Rocks break down in two ways. Physical weathering makes rocks smaller but does not change the rocks in any other way. When a big rock falls from the side of a cliff, it breaks into lots of smaller rocks. All the minerals in the small rocks are the same as the minerals in the big rock. When rocks get hot and then cold, they can crack. Sometimes water gets into cracks in rocks. Water expands when it freezes. It can expand enough to break big sections of rock along the crack. When ice melts, the rock may break into smaller pieces. Physical weathering of cliffs. A rock weathered by freezing and thawing of water. Roots of trees and bushes can grow down into cracks in rocks. As roots grow, they make the cracks bigger. Sometimes the cracks get so big that the rock falls apart. When rocks bang into one another, they get worn down. Rubbing, grinding, and banging is called abrasion. Abrasion is a kind of physical weathering. It happens when rocks fall in landslides, tumble in flowing water, or crash around in waves. Wind can blow sand against rocks. This sandblasting weathers the rocks. Tree roots grow and break rocks. Sand abrasion on cliffs. Sand carried by wind can weather rocks into interesting shapes. Next, I want you to watch a video that explains weathering, particularly physical weathering, in a little bit more detail.
In this video, I'm going to give you a brief introduction to the process of physical weathering, which is also known as mechanical weathering. As you know, weathering is when rocks are broken down into smaller pieces. Well, this happens by a number of different processes. Today, we're going to look at physical weathering, which means that these rocks are breaking apart due to a physical change. In other words, nothing is changing chemically about these rocks. They're still the same rocks, they are just smaller pieces. In a few days, we're going to learn about chemical weathering, which is when rocks break apart because their chemical composition is changing. So there are 5 main types of physical weathering that we're going to look at. The first one is called frost action, or frost wedging. When you look at this rock, it looks pretty interesting because it's obviously all broken up, and you can almost imagine just pushing the pieces back together again and having them fit. That's pretty typical with frost action. Here's another image of some rocks that were broken apart or cracked by frost action. The way this process works is that when it rains or snows, water will get into little tiny cracks or joints within a rock. If it's the winter time and the temperature drops below freezing, the water then freezes. We know from our earlier study of density that when you freeze water, it expands, making it less dense. So when the water freezes and turns into ice, it expands and it breaks apart the rock from the water that was in these cracks. In order for frost wedging to happen, or frost action to happen, you need to have 3 things. You need to have water, you need to have a crack or opening in a rock, and you need to have a repeated series of freezing and thawing events. In other words, the temperature has to drop below freezing, and then it has to go above freezing, and then below freezing and above freezing. In New York, frost action is quite common. We see this happening every winter. Here's another image showing the process of water went in the cracks, the water froze and expanded and broke apart the rocks. These pieces are falling off of this rock face. The same thing happens when you put a can of soda in the freezer, right? When water, soda is mainly water, when water expands, or when water freezes rather, it expands, and it actually will burst right through a can. That's how powerful it is. This picture was taken at the Bronx Zoo. All over Westchester County and all over Manhattan and New York City and the Bronx, you can see evidence of frost action. This picture was also from the Bronx in the New York Botanical Gardens. And you can see this clean cut here means that this was once connected and water got in the crack and froze and it expanded and broke this piece off. All of the rocks, all of the debris at the bottom of this cliff most likely was caused by frost action when rainwater got into little cracks along the face of the cliff and then the water froze. In New York, we also see evidence of frost action in the wintertime when potholes form. Potholes form in the same process. Basically, water gets into little cracks in the road, and then at night, when the temperature drops below freezing, the water freezes and expands, and it basically weakens the asphalt, the pavement, and when cars drive over it, it breaks apart, and you get potholes. Okay, so that's the first type of physical or mechanical weathering. The second type is called biological weathering. And we know that biology refers to life. So biological weathering is when rocks break apart due to living things. I'm sure you've seen trees that are growing out of rocks. Well, the roots of a tree actually can break apart rocks. These trees that are growing on this cliff are slowly breaking the rocks apart. If you enjoy rock climbing, this ends up being great for you because it gives you the surfaces needed in order to climb. You've probably seen in New York City, you've probably seen trees that are breaking apart the sidewalk. So the roots of trees are very, very strong. You may have even seen grass growing out of your driveway or grass growing right up through the sidewalk. It's amazing to think that a blade of grass can actually break apart cement or rocks. And of course, we know when we play rock, paper, scissors, well, this picture shows you how paper beats rock. Now, biological weathering would also include living things. So any organisms that dig underground are agents of biological weathering. So whether it's a dog digging or meerkats or even worms, worms actually eat rock. So they break it apart. And of course, people, we are agents of biological weathering. If you've ever thrown a rock, if you've ever kicked a rock, if you've ever moved a rock, chances are little bits of it broke off. So those are all types of biological weathering. The third type of physical weathering is called wave action. And this is caused by the pounding of ocean waves over rocks over hundreds and thousands of years. If you've ever gotten knocked down by an ocean wave, you know how powerful they are. So imagine waves crashing on the shore for hundreds or thousands of years. They can cause sea arches, like this one, or sea stacks, such as these pillars of rock. At one point, this whole shoreline would have been filled with rock that was up to this height. And over time, the ocean waves broke away all the rocks that are now missing. You may have seen a sea cave at some point. Or possibly these weird rocks, they kind of look like mushrooms, and the bottoms are narrower because that's where the waves hit the rock. And so the bottom of the rock starts to weather or break apart over time. So these are all examples of wave action, which is a type of physical or mechanical weathering. The fourth type of physical weathering is called exfoliation. And exfoliation usually creates these domes, known as an exfoliation dome. Here's how they form. Imagine that you have layers of rock, and underneath that you have magma. You have this hot melted rock. If the magma starts to rise up, it's going to push against these horizontal layers. So what will happen is over time, these horizontal layers are going to get folded. If the magma cools underground and forms an igneous intrusion, then because it's underground, it is confined. It is trapped by these rocks. And so it's going to cool in the shape of a dome. Over time, if these upper rocks get worn away by weathering, what happens is it allows the magma underneath to expand. Because if these top rocks are gone, then this solid rock is no longer under pressure, and it's able to expand. And when rock expands, it cracks. And so what you notice is in exfoliation, the top layer of rock is going to be all cracked because it's no longer underground. It's no longer under pressure that was keeping it together. So here's another picture of an exfoliation dome, and you can see the outer layer is all cracked up because these rocks were able to expand when they were no longer under pressure. This is an exfoliation dome in Africa. Same idea. And the last type of physical weathering that I'm going to talk about in the video is called abrasion. You may have learned in health class that if you fall and scrape your knee, that's called an abrasion. Well, these rocks have been broken down by abrasion. If you look at the rocks, what's the first thing you notice about them? You probably notice that they're all very round and smooth. Abrasion happens when rocks bang against other rocks, and these sharp edges start to break off, making the rocks round and smooth. Tomorrow we're going to take a closer look at abrasion, and we're actually going to do a lab where you're going to simulate abrasion happening in a stream. See you tomorrow.